Welcome to another video from Old Guy Physics, and in getting ready for the next test that we have here at LCA, I wanted to try to produce a couple of videos on projectiles. Okay, and so the first of all the different projectiles, you may remember, looked a little bit like this. We had a table that was set up, and we were told that the table had a height of 1.2 meters and that there was a ball that was rolling across the table at 3 meters per second. Now, we know that during this period of time that it's on the table, it's only moving horizontally. But when it gets to the very edge of the table, we all know that the ball is going to follow a curved pathway and land somewhere over here as a result of the vertical motion that also that's a part of this problem. So here's what we need to know. We need to know that the formula for horizontal says that d sub x is equal to v sub x times t, where x is the subscript here that indicates that it's horizontal motion. So the distance that it travels horizontally is going to be based on the velocity that it's traveling horizontally, which happens to be this value right here, times the time. In class, we said that the time that it takes to travel and hit the ground is based on the time it takes to fall. Well, we had two free fall formulas. One of them said that v sub y was equal to 10t, and the other one says that d sub y is equal to 5t squared. Well, based on the information that we have there, this 1.2 meters is d sub y. So we're going to use this equation right here to solve for the time it takes to fall. So let me grab my calculator. And we have 1.2 divided by 5 equals square root, and t equals 0.49 seconds. Now, that 0.49 seconds that it takes to fall is the same time that the ball has to travel to the right. So this 0.49 seconds can be substituted directly into this equation right here. And so we've got 0.49 seconds right here, and it had a horizontal velocity of 3 meters per second. So then when we run that calculation, we have 0.49 times 3, and that shows us that d sub x is equal to 1.47 meters away from the edge of the table. Now, this is what we call in class horizontally only, because it's only traveling horizontally, and then once it goes off the table, it's falling as it travels to the right. So all the problems that show something that's moving initially horizontally and then it begins to fall, we use that problem. Do you remember? I had a picture of an airplane, not a great picture, but a picture that looked like that. It had a bomb attached. And as it was traveling to the right, it released the bomb, and the bomb lands somewhere on the ground over here. And like the ball on the table, the bomb was only moving horizontally at some altitude, right here, some altitude. And so if we could use that altitude to figure out the time it's going to fall, then we attach that to this equation and figure out the velocity that the airplane is traveling, and we can locate the position of the bomb when it hits the ground. Both of this, the airplane problem and the table problem, are ones that we have worked in the past. You remember, these are the free fall equations when we were just working with vertical stuff. And then this formula right here is the horizontal formula for the horizontal motion. And again, another thing that we should remind you is, remember that vertical and horizontal motion is independent of each other, but they have the time in common. Now, if you have any questions about this, contact me or get in touch with me in class, and I'll be glad to help you. Thanks for watching. Have a great day.